All right, folks, so let's go take a look at transformations again today. We learned how to translate an object. That's where we slid it left, right, up, or down. Today we're going to be focusing on reflecting an object, okay? And it's still going to be the same size after we do it. And then after that, we'll kind of practice a little bit more together here. So reflections. Always take the time to shade in your line of reflection. I promise you, if you don't take the time to do that, you will make a mistake at some point. Not always, but sometimes you will. They say, please reflect this across the x-axis. So take your pencil and just shade in the x-axis. Not real dark, but just enough to go, hey, this is my line of reflection. Now, it's a pretty simple concept. If we're reflecting something across the x-axis and our point is above it, how many units above or below the axis is it? Well, they should be the same. They should be the same on both sides of that line of reflection. So let's look at G. You can see that if we counted down, it is 3 blocks above the x-axis. And so we just want to go 3 blocks below on the other side of the x-axis. So 1, 2, 3, and that's where my G prime would be. And you can notice that G prime is the same distance from x-axis that your G was. Okay, so we've reflected it, and this line of reflection, this x-axis, is almost as if we folded a paper, and this was wet paint up here for the G, and when we folded it over and it touched this other side, it made that mirror image right there, and we would say, hey, this is the new spot, this is the G prime, this is the print that was made there. So what happens if we're using the x-axis, excuse me, not the x-axis, the y-axis? Well, let's go and do this. And imagine that we folded this paper over and it left a perfect print over here on this side. Well, how can you figure that out without actually folding the paper? Well, just count how many blocks you're to the right of the y-axis. In this case, we're 3 away. So now just go 3 on the other side, and that's where the J prime should be. Okay? Same distance from the right to the y-axis, and then from the y-axis to the left, it should be the exact same distance. We're reflecting it. It's making a mirror image. Okay? So how does this work with these shapes like this? Well, first off, again, if it says reflected across an axis, take the time to kind of shade in on there because that's what you need. So there's our x-axis, and take it one point at a time. You choose one of these points. I'm going to choose this S. So how far below this x-axis are we? 1, 2, 3, 4, 5 blocks below. So now we got to go 5 blocks above. And that's where our S prime should be. Okay? 3 more of these points to go. How about we use the T? The T is right here. How far below is it? Just 1 block. So let's go 1 block above it. There's our T prime. Now, this part gets a little bit dicey. Let's take a look at this V right here. How far is V below the x-axis? You can see right here, this red highlighted square right here is showing you it's 1 block below. So let's go 1 block above, and that's where our V prime should be. Okay? Now, this one causes an issue. This U is on the axis. So what do we do with that? Well, we just go ahead and we make another point right here, and we say, hey, if U's on it, it's 0 away from the axis. We're just going to go ahead and make that point just a little bit bigger, and we're going to write U prime somewhere close to it to say, hey, that U and U prime are in the same spot, and that's okay. Now, it's fine for 2 points to share the same location. That's okay, as long as it's on the line of reflection. But what do we do after we've done? I keep getting interrupted. Sorry about that. So here, what can we do with all of these points that are sitting here? Well, we need to go connect them. Now I see that U is connected to T, so how about we take U prime and connect it to T prime, etc. T is connected to S, so I'm going to take my T prime and connect it to S prime, right? And then, you know, S prime to V prime looks like it should happen. Let's go check over here. Yeah, S to V. And then V prime to U prime. Yeah, because V connected to U. Yes, they're the exact same size. Now let's come over here and let's do this one across the y-axis. So we're shading it in here. This would be a lot easier. Let's just take a look at this G. How far away is it from it? It's 1 block away. So let's push it to the other side, 1 block away, and there's my G prime. Let's go to F. 1, 2, 3. So now we're just going to push it to the other side by 3. 1, 2, 3. And obviously F and G are connected, so F prime and G prime would be connected too. Let's go back and do the very last one here though. E. 1, 2, 3, 4. So let's push it over here by 4. Connect the points. You'll see that I actually erased my F and moved it up here so that way it doesn't get in the way of me drawing the lines. That happens quite a bit. And there we have it. It's very important that you actually take the time to label these points correctly though. Okay, don't just like put the points and not label them. We need to see what that is, especially on rotations coming up. But again, yes, my triangles are the exact same size. So now we know how to do 2 of the transformations. We've already looked at translations on a previous lesson. We've done reflections today. Again, the shape is still the same size after we do it. Go practice and let me know how it goes.